Normally we like to have our functions already solved for y. So you'll see functions like f of x equals something, 2x cubed plus 9, okay? And it's already solved for y, so f of x represents y, and it represents the y-axis. We would have y equals 2x cubed plus 9. And in the case where we don't have this, we may have something, for example, like 3x plus 2y equals 7. It's fairly easy to solve for y because y is to the first power. Okay, we haven't really talked about anything where y is not to the first power. So in this case, it's really easy. You just say 2y equals negative 3x plus 7, and then divide everything by 2. Y equals negative 3 halves x plus 7 halves. And you see you have a line, slope-intercept form, and you're good to go. But that doesn't always happen. Sometimes we have a function, for example, this right here, where we have x times y, okay, already starting to be weird, and we have a y squared, okay, again, not normal. So in this case, we'll have what's called implicitly defined functions. And the truth is that this is not, strictly speaking, a function. And we'll see why in 1 second. So let's work with this a little bit, and it takes a little bit of a trick, okay? So this polynomial on the left-hand side of the equal sign can be factored. May not be obvious to you, but let's go ahead and try to factor it into two binomials. Okay, forget about the right side. We'll just leave it alone for a second. How do we factor this? So we know we need an x here and an x here, and look at this, y squared. We know we need a y here and a y here. Okay, so we're pretty much already there. The only thing that could happen is we could have two negatives, right? Or we could have two positives. That way, two negatives would multiply to give us positive y squared, or two positives would also do that. So let's go ahead and double check to make sure this is right. We'll multiply outsides and we'll get xy. Let's multiply the inside and we'll get yx, which is the same thing as xy. Add them together and you get 2xy, which is the middle. Okay, so we did it correctly. It's all factored and ready to go. So now look what happened. When we factored it, we got the same exact thing twice. Okay, let me erase these lines real quick. And so what do we do when we have the same exact thing twice? Well, that is x plus y squared equals 1. Okay, now we have something squared, which is helpful because we can then take the square root of both sides. And when we take the square root of both sides, remember we get x plus y equals, what happens to this side? Right, plus or minus the square root of 1. And what's the square root of 1? It's just 1. Okay, great. So now we have this. Can we solve for y? Okay, great, we can. So we get y equals negative x plus or minus 1. Now, this is a little bit weird. So let's go to a new page. Let's see. We had y equals negative x plus or minus 1. What does that really mean? It means two equations. Y equals negative x plus 1, or plus or minus, right? Y equals negative x minus 1. Okay, so we got the plus or the minus. So can we graph these two equations? Let's go ahead and try. I'll graph them in different colors. Let's say blue for this one. Okay, we got blue here. This is a y-intercept of 1. Okay, so we go up to 1. 1, 2, 3. Then just put some markers on this real quick. 2, 3. Okay, so in blue, let's go up to 1 and put a dot, and then our slope is negative 1. So that means go down 1 and right 1. Put another dot. Then we're going to connect these dots, and that will be the graph of our blue line. Okay, let's do the other line in red. And this one, the y-intercept is -1. And then the slope is the same thing. Okay, that's really important. We have parallel lines here. So we're going to go down 1 and right 1, same as we did before. And connect our dots, put our arrows. Okay, so we get our two parallel lines. So this is the graph of the implicitly defined function. Both the blue and the red lines together comprise the graph of the function. Now the question is this really a function? Because to be a function, it has to pass what? A vertical line test. And does it pass a vertical line test? Let's use yellow to see. Crosses in two places. Okay, not a function. So what we say for this, we call it an implicitly defined function, meaning that it's not really a function, but two functions or more are defined by the equation. So the equation, it defines multiple functions, okay? So we have, in this case, two different ones. So you may have to work for a little bit to come up with them. Remember, we started with this, and this may not be perfectly obvious how we needed to solve it. But the more practice you have at it, the more that it will become obvious to you. So I'd recommend struggle with it a little bit. That way you can learn, train your mind to think of new patterns and new ways to solve problems. And then you can maybe ask someone for help who has an idea of where to begin. Great.